Three airplanes of identical technical specifications and airspeeds of 260 kilometers per hour depart from an airport on a day when the wind is blowing from west to east. Okay? At speeds of 45 kilometers per hour. Okay, so we can assume that the wind is pushing the planes at 45 kilometers per hour. Plane A sets a heading of 17 degrees west of north. Plane B orients itself due north. Plane C orients itself 17 degrees east of north. Okay, so this is a vector addition problem. So after 15 minutes of flight, which plane has gone the furthest north? Okay, so if we just look at the planes, so really what we got here is, we'll do A, which is like this. So we have, we'll do it kind of like this. So this is A. This will be velocity A north. Now I call this Y. There we go. AY. Velocity AX. And then we're going to add on to that velocity, we'll call it wind. So what happens here then, and this is 17 degrees, and so the total velocity of plane A is going to be, let's see here, I should probably actually break this down. So we know we have 17 degrees here. We got this angle. So VA will be, what is it, 260 times cosine of 17, which will be about the sine of, let's see if I can do this, 260 times the sine of, what is it, 72, which is like, I don't know, 240. Go to our calculator. Clear, mode, click, click, degrees. So we have, 260 times, let's do cosine of 17. It's like 0.95, 0.98. So 248. So we have 248. Now I'm going to find the sine. VA, this is Y. This will be X. So we'll do the same thing, but this will be 260 times sine of 17. All I'm doing is I'm breaking down the vector and doing its component parts. So it'll be 76. Well, that's not too bad. 76. So if we look at this plane right here, this is going 76 this direction and 248 that direction. So the concept here, look at the first one, which plane is furthest north, basically which one is going fastest north, is going to be the one that has initially all of its speed in the northerly direction. So in the more mathematical terms, it'd be 260 times cosine of 0. Cosine of 0 is 1, and so you're left with just 260. The wind, even though it might increase the overall speed, it won't increase the speed in the northerly direction. Since the wind is perpendicular to north, it doesn't affect north at all. Therefore, the plane that goes the most north will be B, because it has the most of its original speed going towards north, and the wind doesn't affect the direction of north at all because it's perpendicular. And that goes back to the idea of vector addition. After 30 minutes of flight, which plane has deviated the least from a line on the ground that runs straight north? Our thought process with this one is going to be, it's going to be between A and B. C, it's already starting going a little bit east, and then the wind is going to push it further east, specifically at 45 kilometers per hour. And we already calculated that the 17 degrees here will contribute 76. So really it's going like 120 to the right. So what we're thinking is, all right, so we have this 76, which is to the left, west, plus we have 45 that's going to the east. Maybe that'll compensate. We'll see here. So this will be a picture of A. So 76, 45. And we're trying to see which one stays most true to north, so to speak. So it'd be 76. Actually, I'm going to write this as negative 76 because it's west. And then I'm going to add 45. And this is going to give us a net result of negative 31. So A can be written as negative 31 this direction and it'll be going 248 north. Well, if we look at B, we're going to have 260 north, but then we're going to have 45 to the right, and so, or to the east. And so what's going to happen here then is it's going 45 miles per hour to the east, which is going to be more off of north than the one that is slightly negative 31. I think this is called a crab angle, where like you're kind of going into the wind, but it's pushing you more towards center. So to go straight, you're actually going at kind of a funny angle. So long story short, plane A here will actually be going the most north because it's only going to be off by 31 kilometers per hour. Where B is going to be off by 45 kilometers per hour, and then C would be by whatever these two add together is 130, 121 maybe? Okay. After 1 hour flight, how far is plane C from the airport? Okay, so we're going to break C down into its components, where I calculated out the cosine of 17. They're both 17, right? Yep, I think they're both 17. Plane A, 17 degrees. C is 17. Yep, both 17. So we have 248 here. And then we have 76 from the, let's see, check that real quick. And that should be the sine of 17. So 260 times the sine of 17 is 76. Yep. And then we're also going to add on the component from the wind, which would be 45. So when we look at this, our total speed, we're looking for the total distance, how far from the airport. So this will be 248. This will be 76 plus 45. And the way I'm going to do this on my calculator then is I'm going to do 248 squared plus quantity 76 plus 45 quantity squared. This will give us the square of the hypotenuse. Now we'll square root that answer, and we should get something bigger than both of them. So 275. Yeah, it seems reasonable. 275.9. Whoop. 275.9, which is right about 277. Does that seem reasonable? That does seem reasonable. Okay, so let's think about this for a second. So after a 1 hour flight, so we're basically multiplying 1 by its speed in kilometers. So we have 248 north, then we have 76 east, plus 45 more east. We find the hypotenuse of those, and that hypotenuse is bigger than either 248 or 76, which it is, 275. Yep, and that gives us the total speed of 275.9 kilometers per hour, multiplied by 1 hour. That gives us about 276, which I'm assuming I made some sort of rounding error, which I probably did. And it should actually be 277. So that's how we approach this problem. It's not too hard. It's kind of an easy problem. It's just dealing with vector addition. But being an easy problem is one of the things you kind of have to be careful with, because you really need the points from easy problems. You're supposed to get all the points from easy problems. That way when you miss some from the harder problems, they kind of balance each other out. So just because it's easy doesn't mean it's not also easy to get the wrong answers. So appreciate it. I hope this helped a little bit. I will see you on the next problem.